So here I am at my 64, and as you can see, I've labeled some of the chips so I can still see what they are, and put heat sinks over the portions where the labels were before, which is not uncommon to do on a 64. But I want to do some measurements and see how I'm doing here. So I'm going to use this Thermapen. You might know it from cooking. It's a very common, highly recommended digital thermometer used for instant read for cooking and for smoky meats and things like that. I found that it works really well because it's got a very fine point and you can put it inside a heatsink and things. And what I'm seeing is that the VIC-II chip, after I've rearranged it this way, you know, without the can cover on and the thermal paste that that connected that. You know, this piece of equipment that used to be that this would touch the top of the VIC and that can would be on there. But I want to leave it open both for serviceability and appearance. But then I also want to leave it open because I just think it'll cool better and get more airflow through there, especially since I've this other heatsink over here. So what I'm seeing is the VIC-II is getting up to something like, you know, 127, 130 degrees Fahrenheit. And I want to see if we can improve that. So my idea is, instead of just putting more heat sinks on there where I wouldn't be able to see the chip, I'm wondering if I can just take another heat sink like this one and kind of piggyback it on here and make a bridge between that heat sink and the edge of the can. See, so now we're at like so it'd be something like, you know, something like this. And that seems to make pretty good contact because these kind of interleave like teeth and I can feel it getting warm already. And then on the other side, it makes good contact with the edge of the can. And I do see the temperature going down when I do that. So what's a good permanent solution for fixing that? What I'm thinking to do is just take some thermal paste and smear it on there and interleave it just the way I did. Smear some on the edge of the can here. So that's a, you know, a non-permanent attachment, but should have good connectivity. So let's do that first. Now, it doesn't have to be pretty or anything. This could be cleaned up pretty easily afterwards. And put some on there like that. And then we're going to put, remember we were reading like 127 degrees or so before. I'm thinking something like that. So we're getting 127 before. And I'm seeing it top out at about 111 instead of 127. So that's certainly effective. So now what we want to do is we need some way so that if the computer's jostled around, that doesn't just fall off and out. So what I'm thinking to do that there is to use some plastic welder, and I'll just put a drop of it on there to bond those two heat sinks together. But I don't mean it to be permanent, right? You can imagine plastic welder isn't going to work that well on there. I should just be able to pop it off if ever I need to get at the VIC and pull it or test it or something like that. I'm making a bit of a mess, but I'm just going to mix some more of this epoxy than I need. And put a dab of it on there, something like that. And we'll let that make sure that's making good contact. It's definitely warm to the touch. So while that's solidifying, why don't I tell you a little bit about this other heatsink that I made over here. So what I discovered, and you can see it in my video about the problem I'm having with this early 64 and the keylog power supply. I'm running on the Commodore power supply now. But basically what I found is with the keylog supply, it was giving 11 to 12 volts of AC here. And that was causing this voltage regulator to go really hot, like over 250 degrees Fahrenheit, really high. Right now, with the Commodore power supply, I found that I can measure it pretty well right here. this particular voltage regulator is getting up to in the low 130 degrees Fahrenheit. So, you know, fully over 100 degrees Fahrenheit cooler than with that aftermarket or modern other power supply. But I needed to cool it off either way. So in my version of the motherboard from 1983, there was no heatsink on this voltage regulator, which is a huge problem, and people know that, and they put them on there. This one as well, a tiny voltage regulator here where I fit a small heatsink too, and that helped. But this one, I just fashioned it out of this aluminum flashing. I used tin snips and cut a piece of it. So, you know, cut a straight band. And then this is the one I tried first, and I decided to make it longer because I noticed it wasn't getting as cool as I wanted, and I could tell that you can read the temperature over here, and it's doing a good job of dissipating the heat all the way across. But just bent it, drilled a little hole in there, put a little mounting screw on there, and ran it, you know, parallel to what would be the top of that cover if it were there. And that's just to keep it low enough profile like these other components, so when the keyboard's over it and the top of the computer's on, you still have a good amount of airflow across here. So while that's setting up, I'll do another personal touch to this, a little tribute to Pulp Fiction. That's reading 110. Yeah, so we dropped some, you know, 15 plus degrees just by building this little bridge from that heatsink over to the can.